This is the last session with Steve Scaysbrook from Birmingham, and we're going to talk about the new technologies that are coming. Hi, Steve. Thanks for
Hi,
coming back to
Jonathan.
me. I was going to get you to talk about what you think is the most important things that we can teach our students. I mean, you've been in the game a long time, but if you looked back and you said, these are the fundamentals that don't change, I suspect that you might talk about Mitchell again.
Yeah,
Um,
without a
because,
shadow of a doubt, his
but,
principles
but the,
were absolutely right. And if you bring him into modern day, you won't go that far wrong.
but of course, there's some new technology coming. But I suspect that some of this new technology is on the side, like the difference between drawing in pencil and drawing in ink, or when we went from T squares to a drawing machine, or we went from a drawing machine to CAD, and that is things like the Vectorworks have got this thing, the parametric design, the marionette,
Yeah,
and what's the other one that's got it? Rhino's got it, the parametric designing
grasshopper.
abilities. Grasshopper. Um, and Vectorworks have brought out this new one, and ArchiCAD have got exactly the same thing, which is the AI visualization, where you can do a quick model and you can put in some prompts and you can get a design of a building, which I think is really worrying, because if you show it to the client, often there are things missing, like just little things like structure and height in relation to boundary,
Yeah,
detailing, and
yeah,
just
small
a few of
things.
those little things. But I saw somebody use it they had a complete design already created, and they used the visualizer to change the lighting, to
Mm,
change the textures, and to change the feel of the inside of the building, to try out different ideas.
mm.
And that to me seems like the right way to go with the AI visualizer. That we don't really want it to design our buildings, because that should really be the role of the architect, to choose, if they were building next to the bird's factory, what's appropriate to go next to that? Are we going to rely on an AI visualizer to choose our designs for us, or is that going to be made up of our sensitivity, and the environment and our site analysis and our, doing all that kind of stuff? We
Mm.
had a long chat with a guy called Terry Boone from Taranaki in New Zealand, and he said that looking back over his career, what he realizes is that there are some fundamentals that never change. So he always started with the site analysis. Where's
Oh
the
yeah,
wind? Where's the sun? What's the context? What are we doing? Are we building next to this building? What does it tell us about that building? What are the functions we have to incorporate? If we overlay those functions on the site analysis, does it tell us where those functions should be? And he said that quite often the designs would come out of that analysis, and that he didn't see that that would change, and it hasn't
yeah.
changed. So
I,
I think that these things are cool, the marionette and the AI visualizer. They're cool tricks, but they're kind of like icing on top of the the stuff that doesn't change. The height of humans, if you sit down, how high should your windowsills be? I go to the
I- I'm
airport, my local airport,
I'm
Stephen.
looking at my shelf now for my Neufords. It's on another shelf.
Yeah,
Jonathan, you're
the
absolutely.
AJ metric. We
Oh,
got one in
yeah,
the classroom.
yeah,
So I go to this airport, and my wife thinks I'm nuts, because I go to this airport and I sit down, and I just get so annoyed that it's just at the wrong height. Why didn't they
yeah,
just drop it down 2 inches? I could have watched the planes come and go, but no, I've got to have it up here.
yeah. Yeah, I'm a tapper. I I tap.
Oh
Yeah,
yeah,
I can't not do it. And when he goes nuts at me,
what's this made
yeah,
of?
I know
And
exactly.
your
As soon as
fingernail,
I tap something, I know what it's made of.
and with your
Just
fingernails
experience
too.
those things.
Tap with your fingernails sometimes. Scratch it.
I
Oh, it's
try
made out
going
of
around try going around a stately home and tapping things and see what happens. Oh, you can't do that.
Mm.
But you're right,
So
Jonathan. You're absolutely right. This whole concept of where the industry's going with electronics is interesting. I mean, Vectorworks, when it first came out, was Minicad, and it was basically a pure. It was just a way of taking the old drawing board and putting it into a computer, because, to be honest, that's all it was. It gave me huge amounts of time because scratching out a line on paper was dangerous and time consuming. But in a computer, I could just either send it to a different layer or I could just get rid of the damn thing in seconds and just redraw it. So it was a great way of moving on from a very old antiquated system, which I loved, by the way. And then all of a sudden, Vectorworks started to change. They introduced new ideas and concepts as they started playing with the code. And to be honest, most of it I liked. And then all of a sudden, we introduced Sheets, which was unbelievably good. Because all of a sudden now I could make a sheet of my drawing, which is in the base layer, and I can muck around with it and I could see how it was looking. The communication was now hugely important because I could see on the drawing how it was going to look. My title block had got data in it that was becoming more interesting the more we did it. And then all of a sudden we started to slowly go, and you can tell me, I can't remember, but one version suddenly went from 2D to 3D. And that was again.
You remember I've been using Minicad since it was Minicad 3 Plus.
Yeah.
And Minicad 3 Plus was three-dimensional. It was rudimentary. We didn't have, but it was the start of that generating in 3D, because when I worked at BDP, we were starting to look at 3D stuff then, and it was rudimentary.
Wow.
Is
that long ago?
That long ago. So, but we would build it up out of planes, triangles often. It was when we did the National Maritime Museum, you'd have to physically construct every column out of I forget how we did it, but it took ages to do. These days, of course, you get the column tool, you put a texture on it, and there it is. You can fly around it and
stretch it,
all the rest of it.
Yeah,
but so it has been there for a long time.
I quite like the idea of 3D. I think it worked. I think sometimes students need to be taken back because the computer does too much for them. You ask them to draw a section and they do it quickly, off straight. All of a sudden there's a section there, but they haven't thought about that section. There's no process of understanding, because when you draw it, you have to go line by line or level by level at the building. And so when you ask them to do a plan section or a proper vertical section through a building, they just do it and they don't think. There's no thinking process that goes on. So I like them to. I say get the detail paper out, and I want something that big. I want you to go through line by line, think about the section. What do you expect to see when that section is created, and then do, because you'll suddenly find that the computer's got one idea of what it needs to show, and you've got another, and you need to make sure that what is needed to be shown is correct. And often as not, Vectorworks and Revit is horrible at it. It just shows you the skin. It doesn't go in and build up to the construction. And so you've got to think about that. And that's what's always been lacking, as far as I can see. But that's beside the point. Perhaps another conversation we need to have. But the way that all of a sudden an industry has come from outside and started to influence us, and that is the gamers. If you look at the way that Unreal has suddenly become a major force in our industry, and the way that they can take a Vectorworks drawing and bring it into a 3D environment within their game, suddenly has got massive rule sets that already are making it work. And it's difficult to try to explain until you actually see it. And because what they've also introduced almost at the same time is this concept that when you drag a drawing in, the base model is still there, connected. So digital twin is suddenly becoming, ooh, what the hell's going on? I've dragged my drawing into this game, but the game is still talking to it can also talk to my model. What the hell's
which is
going
really
on?
useful because you change the model and the game updates or the twin
Yeah,
motion updates.
yeah. I mean, it works both ways. So the moment you
But there's
take it
still
in,
a
the link is there. So you can all of a
but there's
sudden you
still
can
a
say to the
danger.
model, tell the base drawing if something is not working, or if the building is now up and running and you've got sensors in that building and the sensors are talking to the game model or what is now become the smart building concepts of that building. It'll then tell to the model, and the architect can pick it up and say, let's have a look at this and see how or why there's a problem. We can think about it. We can use the electronics to do what it's never been able to do before. We can use our expertise, we can draw it, we can understand it. And if there is a problem, we can refix it. So this is the next big game changer. Not allowing the CAD program to take over design. You're absolutely right, wrong. We need to make it work for us again. And all of a sudden, this digital twin thing is making it to work for us because we can go back into a model. And I can say to the AI that's now fixed onto it, just give me a view of the last 2 weeks. Show me what's happened to that detail. The AI doesn't have to think why, it just does what you say. And it shows you a series of details where the detail's gone wrong over a period of time. And you can fix it. You can use your expertise, your building construction knowledge, your 50 years in the business to go back and say, I can see what's going on there. The AI doesn't have to know. All it knows is it must show you all those things and quickly so you can make a decision. So I think if there is one game changer that's come up is this business of the gamers coming into our industry. The second one is we've got to make sure that we understand why it works that way. Don't leave it to the gamers to sort out. Don't leave it to Unreal. We've now got to come in and start the coding process. So one of the things we've been looking at the university, and it's happened on two big KTPs I've worked on, where the architectural trained person, whether they're an architect or whether they're a technologist, are now beginning to code. We teach them to build. We teach them the nuances of putting a brick down correctly, the mortar joints, everything else he needs to understand, how to detail, drip details, joists, your wonderful lattice beams, with the metal things on the outside, which we don't use very often when we do now, but only because of the influence of Australia and New Zealand. And so we're starting to think about how things go and the detailing of it. And now we've got to start thinking about how we can get the building to talk to us and say, I've got a problem. You designed me. There's a problem. And the coding needs to be done to do that. And that's where I see Dynamo, Marionette, Grasshopper particularly, and a lot of other visual coding things. And that's the other thing that's come up that's been interesting, because it's not code any longer. It's blocks of code that you can drag in and join together with electronic string. I remember the lecture that you gave, way back, where you started to explore it. And what did you do? You built a dormer window, showing how a dormer window could be built up using this sort of stuff. And the moment you did it, I thought, yeah, John's got it. He's building something, he's not drawing it, he's building it up with his knowledge, but not telling the computer to do it, which means it would be probably wrong. But you're using your knowledge of coding to make something, rather than drawing it, you're using code to describe it. And that is correct, because at that point
So,
you're starting to think about how the drawing, no, how the detail should look and how it should feel and work. The computer is just doing what you're telling it to do.
but you've mentioned a couple of times now. You didn't use the word experience, but you're talking about building knowledge.
Yeah,
And so for
that's
a
good.
student, they haven't got the building knowledge.
No,
And so what are the important things that we have to teach them? For example, I still think it's important to teach them how to draw with a pencil. And I
oh,
make them draw with a pencil and a T-square and a set square,
we're old
because
school, mate. We're old school. We that's
not
what
just
we
old.
teach.
Well, it's not just because we're old school. I think that because we were old school, we learned something that the CAD programs don't or aren't able to teach us, and
No,
that is line weight, line control, line style.
Absolutely.
Those are the things, because when we move the student into CAD, they'll expect the computer to do those things and it won't. But we need the student to understand why we've got line weights, because in a lot of ways, this comes back to your very first conversation, which is, you called it the international language of drawing.
Oh, yeah.
And if we don't teach them that language right at the beginning with a pencil, what does a concrete hatch look like? What does the two crosses on timber mean? What does one cross mean? What does the wiggly lines mean? We have to teach them that. And the only way to teach them that, I believe, is with a pencil, and like a soft pencil, and I like that detail paper. I call it butter paper, because and I didn't use that until I got to England, but I love having it. And when I go around the classroom and I'm helping my students, I've got the roll in my hand and I've got my fountain pen, and I they say, I've got this problem with my bracing, I've got this problem with my detail. Tear off a piece, sketch it out for them. Oh no, let's have another go at that. Give them a couple of pieces. So there's a lot of stuff there.
I think that buy it themselves. I mean, I tell them to go and buy a roll on Amazon. 17 quid a roll. It'll last you all year. That's important, John.
But there's those things that I think that we teach that last them their entire life. The physics principles, the 4Ds of like how to draw a good detail will last them their entire life, whether they're coding it into the computer or whether they're drawing it by hand.
Mitchell's, when you go through that brief that I sent you, you'll see that there is very little CAD in it. It's all, the first chapter is drawing, how to use a pencil, what pencils to buy. Stadler do a very nice tin of materials. Go and buy a Stadler tin of pencils from B all the way to 5H or whatever, it's 6H or whatever.
If they get out of 2H, I'll say, just grab a chisel, it'll work just as well.
Yes.
Because, by the time they put pressure on the piece of paper with the 4H, even if you rub the line out, you can still see it. You can run your finger over it and feel it.
Wendy's just gone through a box, and this is an old propelling pencil that I think came from India, because their parents were out in India during the pre-partition area. But I still use this now to this day. It's about 100 and something odd years old, and it is brilliant. I draw with it, I sketch with it, and my students say, can I borrow this? No, go and buy your own, because this never leaves. I don't want this being left somewhere. But I carry this around, John. This is everything. All my drawing, my scales, my different felt tip pens, which I'm solely doing, and these things, Stadler rubber.
Steve, I think we've probably reached the end. We're just chatting like old friends, which is what we are.
We are.
So it's time we wrapped up the webinar. I'd love to thank you very much for giving us your time. You're so generous with your time, and I really appreciate it. And I hope that people have enjoyed listening to you talk about the good old days, but also the good things to come. Remember, the principles that we learn, the fundamentals, are going to be with you forever.
Absolutely. Always, John. John, thanks very much for the time you've given me.
You're welcome, Stephen. It's been so much fun. Thanks a lot.
Cheers, pal.